So we are going to tackle 1986 AMC8. Suppose one of the 8 lettered identical squares, so 8 lettered squares starting from A to H, is included with the 4 squares in the T-shaped figure outlined. So which is the T-shaped figure here? So you see this. This is the T-shaped figure. Now we are going to include one of these letters with this T-shaped figure, and the resulting figure should be a topless cubical box. Now you know that a cube has 6 sides. Now we want a topless cube, right? Topless. So that's going to have 5 sides. So we already have 4. We are going to include one of this, and we should be able to tell whether it will actually fold into a cube or not. So suppose I'm going to use A here. Okay, I'm going to include A with this 4. This is going to be the fifth side. So if A is the fifth side, obviously I can fold this into a cube, right? You can see this formation here. So A is possible. So if A is possible, then look at H. H is just the opposite of A. Now this one, this 5 squares including H, this is also possible combination to make a cube. Now let's look at B. So, and let's just undo A and H for now. Now let's look at B. So if I'm going to include B, obviously this one here, this is also possible to be folded into a square. Okay, so if B is possible, then obviously F is also possible because this is just the opposite of B. Okay, so these both are also possible. Coming back, so now we know that A, B, F and H are possible. Now let's look at D. So if I'm going to include D, obviously it's possible because it's making a perfect cross or a plus shape, right? So this is possible to be folded into a cube. Now let's look at the other 3. C. Now there's a problem with C. If you see here, it's attached at 2 sides, right? So obviously when this is going to be included, we will not be able to fold this shape into a cube. Okay, so C is not possible. If C is not possible, G is just the opposite. So G is also not possible. So there goes 2 numbers, not possible. Now let's look at E. So if I include E, obviously it's possible to fold into a square. It just attaches on one side and it's just an elongation of the same T, right? So we can fold. So the possibilities we saw are A, B, D, F, H and E. Okay, which are totally 6 possibilities. So answer option E. Going to the next question. Alan, Beth, Carlos and Diana were discussing their possible grades in mathematics. Alan says, if I get an A, so if Alan gets an A grade, okay, that means Beth also gets an A grade. Okay. Now, if Beth gets an A, she says that if I get an A, Carlos will also get an A. Okay. And if Carlos gets an A, he says that Diana also gets an A. Okay. So now all these statements were true, but only 2 of the students received an A. Which 2 received A's? Now let's check. If Alan receives an A, then obviously all 4 will receive an A, right? So Alan gets an A, that means all 4 have to receive an A. It's all connected. If Beth gets an A, now remember one thing, when Alan gets an A, Beth gets an A, but Beth gets an A, Alan doesn't get an A. So this inverse is not true, okay? So if Beth gets an A, then obviously Beth, Carlos and Diana end up getting an A. So 3 A's. So if Carlos gets an A, okay, only he and Diana will get an A. So 2 A's. And if Diana gets an A, only she will get an A. So it's 1. Now we are looking at 2 true statements, which is this. Okay, which means Alan and Beth got other grades, which is fine. So we are looking at this. So this is your answer option C. Carlos and Diana, they too get an A. Going to the next question. The large circle has diameter AC. So this AC is the diameter of the large circle. The small 2 circles here, they have diameter from O to C, right? And the radius is 1 for the smaller circles. Now the question is, what is the ratio between the area of the smaller circle to the area of the shaded region? So first we are going to find the area of the smaller circle. So I'll say area of small circle, which is equal to, so if the radius is 1, the area will be pi, right? So pi r square, 1 square is 1, so pi. And we have, now we have to find the area of the shaded region, for which first I'll find the area of the big circle. Now the big circle has a radius of 2. So 2 square is 4 and pi. So area of the big circle is 4 pi. Now I'll find the area of the semicircle. Okay, semicircle. This will be, semicircle is this, like AC, which makes a semicircle. This will be 4 pi by 2, which will be 2 pi. Okay. Now for the shaded region, from the semicircle, which is 2 pi, I have to reduce the area of a small circle, because I have a semicircle here, I have a semicircle here. Together they make a small circle. So area of the small circle is pi. So the area of the shaded region is 2 pi minus pi. So the area of the shaded region is pi. So now if I uh, see the ratio, it's nothing but pi is to pi, right? Which is 1. My answer option is B. Going to the next question. 600 students in King Middle School are divided into 3 groups of equal size for lunch. Okay, so we have 3 groups. Okay, each group has lunch at a different time. A computer randomly assigns each student to one of the 3 groups. The probability that the 3 friends, Al, Bob, and Carol, will be assigned to the same lunch group is approximately. Okay, so for them to be assigned to one of the lunch groups, the probability is 1 by 3, right? For being assigned to the second lunch group, the probability, so for Al to be assigned to one lunch group, the probability is 1 by 3. Similarly, for Bob to be assigned to the first lunch group, 1 by 3. Carol to be assigned to the first lunch group, 1 by 3. So it is 1 by 27. But there are 3 such groups, right? It's not just one group. There are 3 such groups. So you multiply by 3. So which is nothing but 3 by 27, which is 1 by 9. Okay. This is your total probability, which is B. Now coming to the next. Which of the following sets of whole numbers has the largest average? Now, when you have a set of numbers which are increasing in a specified manner, so the common difference is the same, then the average of the first and the last number is the average of the group of numbers. Let me show you. So suppose I have 2, 4, 6. Okay. Now the average of this is going to be 6 plus 4, 10, 12 by 3, which is 4. This is also the same as 6 plus 2 by 3. Okay. So if I 6 plus 2 by 2, okay, the average of the first and the last number is nothing but 8 by 2, which is also 4. So this works for any number of items within the group. Okay, only thing is the common difference, the difference which with which they increase should be the same. Okay, so this logic holds. So going by this logic, okay, so going by this logic, the first one, multiples of 2. So starting number is going to be 2, ending number is 100. The average of this is 102 by 2, which is 51. Now looking at 3, starting numbers 3, ending numbers 99. So again 51. Then you have starting number as 4, last number is 100. So this is 52. Okay, then you have here 5 and 100. So this becomes 52.5. This becomes starting number 6 and ending number 96. Right? So this becomes again 51. So this is your largest average. So your answer option is D.